So today is Wednesday. We're going to quiz tomorrow. That's going to be Thursday, a Thursday quiz. What is your quiz going to look like? You're going to have to list the identities, all of them. I'm going to say like reciprocal identities, and you're going to list them all. I'm going to say ratio identities, and you're going to list the two. I'm going to say even odd identities, and you're going to list them. I'm going to say PIDs, and you're going to list them. I'm going to say cofunction identities, and you're going to list them. Okay? Yeah, yeah. It sure is a lot. I expect you all to know a lot. That's tangent and sine over cosine. Yeah, they're called quotient identities or ratio identities. They're in your notes. And then you're going to have one simplifying, one where you're simplifying to a single power of a trig function, and then you're going to have one solving. So there's your quiz. It'll be at least, bless you, 10 minutes. At least 10 minutes. Probably closer to 20 minutes. Simplifying. All right, have we forgotten what we've been doing?
No, I can't remember.
Simplifying. That's what we did on example 6.
Oh, okay.
Where we get down to a single power of a trig function.
Yeah.
You'll have one like example 6, and then one like example 7, 8, 9, and 10. Okay? And 11. All right, now we are on example 10, so let's go for it. Find all the solutions such that, look at this. This is the official letter for the American Psychological Association because it's the letter PSI, and you pronounce it psi, and that's the first sound that you say when you say psychology. So that's just PSI. That's the Greek letter psi, and we're from -4 pi to 0. So notice that's two negative rotations. That's two negative rotations. Now, guess how we're going to find the values in two negative rotations? We're going to find all the positive ones within one positive rotation. That's our wheelhouse, our comfort zone. And then I'm just going to subtract 2 rotations from each of those. Okay? And then breathe a, look at this. I'm trying to be funny. Then breathe a what of relief? Sigh of relief. Oh, we're done. Y'all didn't even laugh. That's okay. I didn't expect you to. I make myself laugh, and that's all that matters. All right, 3 sine of psi equals 2 cosine squared of psi. What should I do? Set it equal to 0. Get everything on one side. So I get 3 sine of psi minus 2 cosine squared of psi equals 0. And as soon as it's equal to 0, we try to factor it. First rule of factoring is a common factor. Do we have a common factor? No, we don't. So we have to do something here. I have a sine and a cosine squared. Man, it would be nice if those were both sines or if they were both cosines, wouldn't it? That would be nice. Hey, in all the excitement of the schedule, I forgot to take attendance. We might have to stop a little bit early so I can take attendance. I know y'all will object to that. So it would be nice if they were both sine and both cosine so I could pull out a common factor. So here's my question to myself. Can I write sine of theta or sine of x or sine of psi? Can I write that in terms of cosine? Or can I write cosine squared in terms of sine squared? I can write cosine squared in terms of sine squared by way of the PIDs, don't I? Well, let's take our time here. I'm going to put cosine squared of psi in parentheses, and I'm going to work straight down, and I'm just going to put minus 2 parentheses equals 0. Cosine squared of psi is actually 1 minus sine squared of psi. That's that other version of the PIDs that I told you show up very often. Cosine squared is 1 minus sine squared, and similarly sine squared is 1 minus cosine squared. Right? So here's what you need to know about the PIDs. You not only have to have them memorized, but you need to be aware that you can write cosine squared in terms of sine squared and vice versa. You can write secant squared in terms of tangent squared and vice versa. And you can write cosecant squared in terms of cotangent squared and vice versa. That's the power of the PIDs. All right. Now, I'm not sure if this is going to bear any fruit, but at least it gives me something to do. I can distribute now, and I get minus 2 plus 2 sine squared of psi. Now it should start looking a little bit familiar to you. You remember we saw this yesterday? We have a squared sign, a non-squared sign, and a constant. That sure looks a lot like a quadratic trinomial in terms of sign, doesn't it? Let's write it in descending order. 2 sine squared of psi plus 3 sine of psi. It kind of also looks like a saguaro cactus, doesn't it? It makes me think that I'm doing this out on the desert plains.
Or Aquaman's thing.
Or Aquaman's trident. Yeah, the thing. Yeah. Or just a fork. Or someone shooting you the middle finger. Right? Maybe.
Isn't that what
Pickled pork?
pickled pork?
Pickled pork.
No, pickled pork.
Pickle fork. Oh, a pickle fork only has 3 prongs, I guess. Yeah. Yeah. Good call there. All right, let's double bubble this thing. We'll keep it equal to 0. 2 sine squared has to factor into 2 sine of psi and then 1 sine of psi. It has to be that. Now 2 on this end is prime, but is it going to be a 2-1 combo or a 1-2 combo? I think it's going to be a 1-2 combo, so I get a 4 on the outside, a 1 on the inside, and it's got to be a positive 4 and a negative 1. So when I subtract, I get a positive 3, and the product is negative 2. So factoring should not be an obstacle to getting the correct answer, should it? Everyone okay with how I factored that? Instead of the 1-2, instead of the 2-1 combo, it's got to be the 1-2 combo. Okay. All right, now I can set them both equal to 0. So 2 sine of psi minus 1 equals 0, or sine of psi equal plus 2 equals 0. And I solve these, and I get sine of psi equals 1/2, or sine of psi equals negative 2. And now guess what time it is? Everybody check your watch. It is unit circle time. But actually, it's time circle unit, because we're really using the unit circle in reverse, aren't we? What are the 2 angles within one rotation, positive rotation, where sine is positive 1/2?
That would be
Pi 6
and 5
and 5 pi 6. Does everybody agree with Brady? And you could find those on your own? Okay, that's good. Now we got to modify those, but I'm just going to leave those there for now. And then we'll mosey over to the second equation. Where does sine equal negative 2? Nowhere. Everyone agree with Brady again? Sine only lives between negative 1 and 1, right? Negative 2 is not a legal sine ratio. So that little branch or that little factor did not bear any fruit. Okay? So that's okay. All right, now we can adjust these right here. So our solutions, we'll do it as a solution set. It's not going to be pi 6. We have to back up a single rotation, and then we got to back up a single rotation again. So one rotation, which is 2 pi, is how many pi 6 did we say yesterday? 12. It's 12 pi 6. So I got to subtract 12. So what's 1 pi minus 12 pi? Negative 11 pi 6. And what's negative 11 minus 12? Negative 23 pi 6. So those are the 2 angles that come from pi 6. And then I got 2 more here. What's 5 pi 6 minus 12? Negative 7 pi 6. And what's negative 7 minus 12? Negative 19 pi 6. And there they are. There's your 4 solutions. Yeah, it didn't say to find all of them, and it didn't say between 0 and 2 pi. We only want the negative angles between negative 4 pi and 0. So we still find the ones we want between 0 and 2 pi, and then we modify them. And there's your solutions. They're all going to be in the domain because we don't have a denominator, so we're good. Nothing to it, right? So what jump-started that whole problem? The Pythagorean identity. We wanted to put all of our trig functions across the board in terms of the same one, sine or cosine. And it was much easier to write cosine in terms of sine squared than it was to write sine in terms of cosine. Yes, yes? Yes, yes. Okay. Questions on number 10? That makes a good quiz problem. I like factoring. So factoring makes good quiz problems. Again, notice how beautiful this is written. Not to brag on my method or anything, but what I mean by beautiful is everything is written straight down. Every line is equivalent to the line above and below it. and then we get down to our final answers at the bottom. Okay? It's very clearly written. Anybody who knows anything about math would be able to follow your work from line to line. Okay? We didn't even have to go off to the side and do any workbench work. It's all right there in the project. All right. Number 11, rapid fire mixed practice. Solve each of the following between 0 and 2 pi. Okay, so I put you back in your comfort zone, right? 0 to 2 pi, this is one positive rotation. That's where we like to live. No calculator required. Okay, let's look at this one here. 2 sine of x plus the square root of 3 equals 0. So far, we've been jump starting all of our problems by getting everything equal to 0, haven't we? This one's already equal to 0. The whole point of getting something equal to 0 is to factor it. Is there any common factor here? No. So what do? What did we do up here when we had 2 sine of psi minus 1 equal to 0? Did we keep it equal to 0? We solve for sine of y, right? So the only time that it makes sense to get something equal to 0 is when you have 2 or more variable terms. I have 2 variable terms there. I got everything on one side and set it equal to 0. Over here, I had at least 2 variable terms. I got everything on one side and set it equal to 0. Up here, I had 2 variable terms. I got everything on one side and set it equal to 0. But our goal is, once we get it down to individual factors, we're trying to solve for the individual trig functions. So if you only have one trig function in your entire problem, your goal is actually not to solve for get it equal to 0. Your goal is to solve for that trig function. Okay, so let's go ahead and do that. I'll do it in 2 steps. I'll bring the square root of 3 across and it becomes negative square root of 3. I'll divide through, bless you, by 2, and I get negative square root of 3 over 2. And now solve for sine of x. That's our goal. Solve for the individual trig function. And now it's unit circle time, or time circle unit, where within one positive rotation, the sine equal negative square root of 3 over 2, 4 pi thirds, and, ooh, close, 5 pi thirds. Yeah, quadrant 3 and quadrant 4. Now you can list your answers like that. You don't have to do it in set notation. If you want to put the epsilon and put the braces, because again, it is fun to make the braces, you can write it as a solution set if you want, or you can just leave it as x equals. I don't care which version you put your final answer in. Okay, so that was rapid fire. That wasn't too bad, right? We learned a little something though. Just because it's equal to 0 doesn't mean we want to keep it equal to 0. We got to solve for the individual trig function. Okay, how many trig functions do I have in this equation? Just one, right? So do I want to get it equal to 0, or do I want to solve for secant squared? Just solve, right? So I want to keep secant squared of x on the left. I'll divide through by 4 and I get 2. And now I'll take the square root of both sides. And what do we have to remember to do when we take the square root? Plus or minus. If you forget that, you're going to lose half of your solutions. That's no good. Now, here's a little trick. If secant is equal to plus or minus the square root of 2, it's easier for us to solve when we're thinking about sine, cosine, or tangent, isn't it? I mean, we can handle secant, cosecant, and cotangent, but we think better in terms of sine, cosine, and tangent. So what could I do to both sides to turn this into something more recognizable? Flip them. Flip them, yeah. If the secant ratio is plus or minus the square root of 2, then the cosine ratio must be plus or minus 1 over the square root of 2. Yes, yes? Because cosine and secant are reciprocals of each other. Well, if I rationalize that now, plus or minus 1 over the square root of 2 is plus or minus square root of 2 over 2. And now I'm back on solid ground. I have a firm footing here. Where is cosine equal to plus or minus square root of 2 over 2? It's all your pi fourths angles, right? Because it can be positive or negative. So let's just walk around the unit circle. Pi fourths, quadrant 1. 3 pi fourths, quadrant 2. 5 pi fourths, quadrant 3. And there's your 7, Brady. 7 pi fourths, quadrant 4. There's your answer. And if you forgot the plus or minus, you're only getting the pi fourths and the 7 pi fourths. You're missing the other 2 solutions. There's no denominator here, so we know those are all going to work. We don't have to worry about in the domain of the solution set. All right. Straightforward. We're on rapid fire mode. Any questions? All right, 4 cosine squared of x minus 3. I have a single trig function now. My goal is not to get it equal to 0, but to solve for cosine of x. So I'm going to bring the 3 across, and that equals that. I'm going to divide through by the 4, and I get 3 over 4. And now I'm going to take the square root of both sides, remembering to do what on the right-hand side? Plus or minus the square root of 3/4. All right, now if I expect you to do these without a calculator, then keep in mind that when you get to this point here, the ratio on the right should be a recognizable unit circle ratio. Here's what I could do. I can give each of them the square root. That's the square root of 3 over the square root of 4, which when I simplify that, gives me plus or minus the square root of 3, which is not reducible, over the square root of 4, which is 2. Now I recognize that from the unit circle, don't I? I'm just practicing my pep rally material right now, guys. We could do this at the pep rally. All right, everybody, get out your iPads. Don't forget plus or minus when you take the square root. All right, so it's going to be plus or minus. So again, it's going to be in all 4 quadrants. What's the reference angle here? Pi 6. So in quadrant 1, it's pi 6. Quadrant 2, it's 5 pi 6. Quadrant 3, it's 7 pi 6. And quadrant 4, it's 11 pi 6. I remembered that I didn't take attendance when I sat here because guess whose desk this is supposed to be? I'm sitting in Cheyenne's desk, and that's exactly what I was thinking. Who normally sits here? Normally. Yeah, normally should sit here. All right, there we go. Any questions? Rapid fire. We're in rapid fire mode. All right, letter D. Sine of x equals cosine of x. Okay, now I have 2 variable functions. So we might want to bring everything to the other side instead of equal to 0. Yes, yes? Okay. Now notice if I do that, there are exceptions to every rule. Finding the solutions is a little more nuanced than just following some rigid guidelines. If I do that, do I have a common factor? No. Ah, there you go. That's what we're going to do. I can't write sine in terms of cosine, and I can't write cosine in terms of sine. Neither one of them is squared. But if they were squared, I could, right? Now, here's the deal. If I were to square it right now, I would have to do square multiply double square. I would get sine squared of x minus 2 sine x cosine x, and then plus cosine squared of x. I would have to get 3 terms. Is that okay? Or should I square it before I bring them across? Yeah, I should square it before I bring them across. You'll see why as soon as we do it. Okay? If I know I'm going to square it, I should square it right away. Now, keep in mind that whenever you square an equation or raise it to any higher power, it raises a red flag. You have possible extraneous solutions. So you got to check for extraneous solutions at the end. All right? So I get sine squared of x equals cosine squared of x. Now I can move everything to one side. Sine squared of x minus cosine squared of x equals 0. All right, now we're back to where we were earlier. I wish that they were either both in terms of sine or both in terms of cosine. Well, can I write sine squared in terms of cosine squared and vice versa? Yeah, so it doesn't matter which one I choose to change. I'll change the first one. I'll call sine squared 1 minus cosine squared. And then that becomes minus the other cosine squared, and I get 0. So here's the trigonometric identity substitution right there, highlighted in yellow. So
Sine squared of x minus cosine squared of x.
no, sine squared minus cosine squared is not Papa Pid. They have to both be positive, or if they're both negative, we could factor out the negative and say it's -1. They have to be the same sign. If they're both positive, it's 1. If they're both negative, it's -1. But if they're different signs, it's not 1. Okay. But now I have common terms here, like terms. So that's 1 minus 2 cosine squared of x equals 0. Okay, now I reassess, right? Now it's equal to 0, but guess what? I've got it down to a single trig function. So what do when I get it down to a single trig function? I solve for that single trig function. So I get 1 equals 2 cosine squared of x. I'll divide through by 2, and I get 1/2. And I'll take the square root of both sides, and I get plus or minus the square root of a half, which if you remember from a little while ago, that's equal to plus or minus the square root of 2 over 2. Now, if I'm listing my solutions because it's plus or minus, I can go all the way around the unit circle, right? With your pi fourths angles, 1 pi fourths, 3 pi fourths, 5 pi fourths, and 7 pi fourths. But because we squared both sides, what did I tell you that should do? Check for extraneous solutions. Okay, they may not all work. If I go back to the very original thing before I squared it, I want to know for what of those angles does sine equal cosine. Now, on the unit circle, that means the sine and the cosine, they have to have the same value for the ordered pair x comma y. The exact same, don't they? All right, at pi fourth, do the x and y coordinates on the are they the same at pi fourths? Yeah, they're both positive square root of 2 over 2. What about a 3 pi fourths? Are they the same? No, x is negative and y is positive. So that's an extraneous solution. What about 5 pi fourths? Yes, they're both negative there, right? But at 7 pi fourths, we have a positive x and a negative y. So the only two solutions that make it that are not extraneous are pi fourths and 5 pi fourths. So that's how you solve it algebraically. Now, if you would have just given it a good thought before you started, could you have solved this one just intuitively? Yeah, you're asking yourself for what angles x do the sine and cosine equal each other on the unit circle. You could have then asked yourself, that means they have the same x and y coordinate. Oh, that's when they're both square root of 2 over 2 or both negative square root of 2 over 2. And you could have jumped to your two answers right away, which is fine if you do it either way. I don't care if you solve it intuitively. A lot of these cannot be solved intuitively, and we're trying to learn algebraic methods for reconciling them, okay? And for this one, it's squaring both sides before we bring it across. Otherwise, we get too much baggage. Okay. All right. Comments or questions? All right. What about this one? 2 cosine squared of x equals cosine of x. Now I have two variable terms. Does it make sense to get them all on one side and equal to 0? Yes. Yeah. Minus cosine of x equals 0. Now in this shape, I'm good. I'm good in this situation. I'm in good shape because I already have a common factor. I don't have to use the Papa Pitt identity to get cosine squared in terms of sine squared. I just factor out a cosine, and that leaves me 2 cosine of x minus 1 equaling 0. And now I can set them both equal to 0, so cosine of x equals 0, or cosine of x equals 1/2. Is it okay to set the second one equal to 0 and solve it in your head as you write it down? Am I okay with that? I'm fine with that. If you could say 2 cosine of x minus 1 equals 0 is going to come out to cosine of x equals 1/2, and you can skip that step, I'm fine with that. You're honor students. You should be able to do that. All right, and now it's unit circle time or time circle unit. Where is cosine equal to 0? Pi halves and which pi halves? 3 pi halves. And then where is cosine equal to positive 1/2? Okay, and someone besides Brady, give me the last one. Where else is cosine equal to positive 1/2 besides pi thirds? 5 pi thirds. Good. Quadrant 4. Do we need to check for extraneous solutions here? Did we raise both sides to a power? Nope. Do we need to make sure they're in the domain? Do we have a denominator in our original problem? Nope. So they're all good. Those are all your solutions, and you can list them just like that. Rapid fire. All right. I got at least 2 variable terms. Do I want to get it equal to 0? Yes. So I got 2 plus 2 cosine of x. Red rover, let sine squared come over. Okay, so now he's minus, and that equals 0. Okay, now I'm at that situation. It looks like a quadratic trinomial, doesn't it? I got a constant, a squared term, and a non-squared term. But the problem is they're in terms of different trig functions. So now I'm back to that same old predicament that I was able to solve twice already. I wish they were both cosine, or I wish they were both sine. Is it easier to change a cosine into a sine, or a sine squared into a cosine squared? Sine squared and the cosine squared. Now pay very close attention to the negative in front of the sine squared. You see that? Here's how I like you to do it. Put parentheses around the sine squared, and on the line below, put minus parentheses equals 0, and then make your substitution. What is sine squared equal to? 1 minus cosine squared. You'll get used to those other versions of Papa Pid. Sine squared is 1 minus cosine squared, or cosine squared is 1 minus sine squared. All right, let's see if we can finish this one here before the bell gets us, because we're in here a short amount of time. If I distribute, I get minus 1 plus cosine squared. And now I write it in descending order, and I get cosine squared of x plus 2 cosine of x, and I get 2 minus 1 is minus 1 equals 0. So then I factor it. That's cosine of x. 2 minus 1. Oh, it's plus 1. Yeah, thank you. So it's cosine x plus 1. Yeah, that was going to work. Times cosine of x plus 1. Well, that's the same factor. So I only got to set one of them equal to 0, which means cosine of x is equal to negative 1. And now there's only one solution. Where is cosine equal to negative 1? No, that's where sine is negative 1. It rhymes with guy. Starts with P. Pi. Cosine of pi is negative 1. And there you go. We don't have to check it because there's no extraneous solutions. There's no denominator, so it works. Okay, so when is your worksheet due? Tomorrow. When is our quiz? Tomorrow. So worksheet is due Thursday, and we'll quiz on Thursday. We did it. All right. I'll see y'all at the pre-cal pep rally. I mean the decision day pep rally.